This is another counting problem, similar to the last one, but if you look at the answer choices, 96, 100, 112, 120, 121, there's going to be a lot more options here, so listing them out one at a time is probably not going to be the best way to go. We need a way to organize our thoughts, and the way that I organized things is by making a table and organizing all of these numbers by the average digit. It says how many three-digit numbers have one digit equal to the average of the other two. And so I went and organized everything by average. And this is what I ended up with. If the average of the three digits is 1, it's possible that all of the digits are 1. That's where we have 1, 1, 1. Or it's possible that the digits are 0, 1, and 2. Now, I know 0, 1, 2 isn't a three-digit number. I'm just listing the digits, and then I'll look at the ways that we can rearrange them later. Similarly, for an average digit of 2, it's possible that all of the digits are 2. It's also possible that the digits are 1, 2, and 3. There, 1 and 3 have an average of 2. And it's also possible for the digits to be 0, 2, and 4. There, 0 and 4 have an average of 2. And I kept writing out all the possibilities, 3 and 4 and 5 and 6 and 7. And when the numbers are smaller or larger, like 1 or 2 or 8 or 9, there aren't that many possibilities. If the average digit is 8, for example, then all the digits have to be 8, or the digits have to be 7, 8, and 9. And if the average digit is 9, the only way that we can get that is if all the digits are 9. So I listed off the possibilities, but we have to look at the different ways that we can permute the numbers to get different numbers. For example, 246 could be 246, or 264, or 426, or 462, or 624, or 642. So we have to look at these and group them, and then figure out how many possibilities there are for each group. First, I want to look at the sets of digits where all three are the same. So we have 3 of the same digits. We've got 111, 222, 333, 444, 555, 666, 777, 888, 999. We have all the bolded ones, and those are 9 possibilities. There are 9 of those, and each one of them only corresponds to one possible three-digit number, because if we rearrange those digits, it's going to be the same number. So each of those 9 possibilities only gives us 1 each, so we have 9 times 1, or 9 possibilities where all of the digits are the same. Next, I want to look at the ones where I have a 0 as one of the digits, where it's italicized. You can see those. So we've got 0 as a digit. Now, we know that those numbers can't actually start with 0, because then it wouldn't be a 3-digit number, it'd be a 2-digit number. So for each of those, for example, down here, let's look at 0, 1, 2. If we're looking at 3-digit numbers, the first digit has to be either a 1 or a 2. If the first digit's a 1, we've got 102 or 120. If the first digit's a 2, we have 201 or 210. So there are 4 possibilities there, and the same is going to be true for all the other ones where they have a digit that's 0. So if you look, there are actually 4 sets that have 0 as a digit, but each of those can be permuted into 4 different possibilities. So we have 4 times 4, or 16 different 3-digit numbers that have a 0 as one of the digits. Lastly, I want to look at all of the numbers in the possibilities column that have 3 different digits and that aren't having 0 as a digit. In each of those, if we look at them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, there are 16 different numbers in that possibility list, but we have to look at how many ways we can permute the numbers to get different 3-digit numbers. Let's look at the example that has 1, 2, and 3 as its digits. Well, it can either start with a 1, a 2, or a 3. If it starts with a 1, it could be 123 or 132. If it starts with a 2, it could be 213 or 231. If it starts with a 3, it could be 312 or 321. That gives us 6 different permutations for each of those sets of digits. The same thing would be true with any of the others. If we looked at 258, for example, we'd have 258, 285, 528, 582, or 825 or 852. So we've got 6 different possibilities for each of those. That gives us 16 times 6, which is 96 different 3-digit numbers that have 3 different digits and they're not equal to 0. And so all 3 of these, if we add them together, 9 plus 16 plus 96 ends up giving us a total of 121 possible 3-digit numbers, and this is answer choice E.